Hello, everyone. My name is Mo. I'm co-founder of Brevis. Just a quick introduction on myself. I did my PhD in computer science in UC. Sold a company in networking security before, and started in the blockchain industry since 2018. Let's start. So, Brevis is a smart ZK coprocessor. So, what is a ZK coprocessor? Well, we have seen blockchain evolution for so many years with layer 2, layer 1s introduced, but there are still blockchains, and these improvements are still not enough in the sense that all of these constructs are still relying on distributed consensus, and the blockchain as a construct itself is generally bad at data-rich and heavy computations. So, using just like directly using a kind of a very relevant example, right? So if you look at every centralized exchanges, they all have something like a trader loyalty program, which basically works this way. You traded a lot in this month, say like you traded like $10 million this month, and in the next month, you get a trading fee discount. And this is how they actually attract a lot of professional market makers and have very efficient price discovery on DEXs directly. And in fact, most of the volume and revenue on these centralized exchanges are actually generated by these traders with special fee arrangement in very high volume. But if we look at every decentralized exchanges, this type of feature simply does not exist. Why is that? Well, it's not because DEXs don't want to implement that. It is actually because to implement that, the cost is extremely prohibitive. So like even if you want to just access a single user's historical trades, let's say in the Uniswap case, if you just want to access like what are the trades that done by this user in the past 30 days, let's say there are 10,000 trades, the cost to actually compute that trades and access that and validate that these users did all these swaps and calculate the total transaction volume or trade volume will cost you 4 hours of block time, fully packed block on Ethereum 4 hours and 20K in transaction fee. And the 20K is actually kind of a lower number that we got last year. This is probably much higher this year. So why is that, right? So if we think about it, how we can actually compute a user trading volume today on-chain directly? Well, it's possible, but it's extremely expensive. First, we need to remember all the historical state root on the blockchain directly. Basically, what are the block patterns that happening in the past, and therefore that we can actually retrieve the corresponding transaction or corresponding event that is generated by this user. And then we need to calculate, let's say, 10,000 Merkle inclusion proof directly on chain, which is extremely expensive. And then we only get this only get us the leaf node. The leaf node is encoded RLP, and we need to decode the RLP to find the actual trading amount, and finally add them up on chain directly. So this operation, needless to say, is extremely expensive. Well, this is a general problem for all smart contracts, not only just Uniswap, right? So if you are a smart contract and you want to access historical on-chain data, such as transactions, events, storage states, who held what token, what is the trading volume, if this user have used that protocol or not, this type of information in smart contract directly, there is no good way to do that today. So there's no trust-free access to historical on-chain data, and there's no trust-free access to data on other blockchains. And the result is that blockchain as a whole is bad at data-driven and very complex computation. So this is where a coprocessor is needed. In this architecture, blockchain can just focus on transactional computation, which is like basically the asset movement, the asset ownership changes, and all that. But the whys of why these assets get moved and this type of data-rich and complex computation driven, that is driving a lot of business logic can be offloaded to a coprocessor that is off-chain, not in the blockchain. And the coprocessor will do the computation and return the result back to the blockchain. But the key thing here is that if we use like an off-chain centralized server to do this, that's fine. It improves a lot of kind of efficiency and capacity, but we lose the trust-free nature of blockchain. So the important thing about this architecture is that we can do this, but we should do this in a way without compromising the trust-free nature of blockchain. This is why we need to use a ZK coprocessor to essentially generate a trust-free proof of these blockchain data that we want to access in smart contract, and also generate a computation proof on top of these data that you need in the smart contract, and then use that ZK proof to verify the on-chain easily and inject the result into the smart contract and drive business logic. So this is what Brevis does. Brevis is a ZK coprocessor that can generate ZK proof of arbitrary computation on really any data. And therefore, it allows smart contracts to utilize these computation results that is based on historical on-chain data and directly in the smart contract in a trust-free way. So integrating Brevis into this application stack is actually pretty simple. So even though it is a ZK build, we actually provide a very easy to use SDK so that developers don't actually need to know anything about ZK circuit writing. So there are really three simple steps here. The first is that you need to read the data you want to read. Like you need to specify what type of data you want, right? So, for example, we support storage state, block information, receipts, which are essentially transaction events, and beacon chain states, transaction itself, like whether this transaction is successful or get rejected, account information like account nonce on all these supported blockchains. And I'm showing a very simple code snippet, and Juna will talk a lot more about this. But this basically, enables you to add transaction events that is relevant to a user's swap event. So this is how you can kind of essentially specify, okay, I'm interested in getting users, trade event in the past on Uniswap. And the second part is to actually do computation on top of these data gathered in the first step. So for the computation, we actually provide some very easy to use data stream APIs where you can basically apply map, reduce, sort, filter, zip, group by based on the data that you gathered in the first step. So this particular example basically shows that how you can, with very, very simple code based on our API to calculate a user's trading volume on Uniswap in the past, right? So, it's very easy to use kind of compute APIs wise. And finally, what you do is that you need to put all these data and computation result back to the blockchain where you want to use it, right? So let's say if you want to implement a trading fee, discount based on trading volume, then this result, this user's trading volume result, will be pushed back to a hook contract, and the hook contract will have some business logic to check, okay, what is this user's trading volume? Is this user trading volume higher than 10 million? Then this user is like a VIP tier 1. If this user's trading volume is higher than 100 million, this guy is VIP tier 3, and correspondingly assign different kind of a discount value for the user, right? So in this example that I'm kind of walking through, so like this kind of a hook contract will be receiving the result from the ZK coprocessor. It's very important to note that once the callback is actually received by the application smart contract, the entire computation and the data validity of the computation is already ZK proven. What basically, in plain terms, what that means is that, if you gave the blockchain a result saying that a user traded like $1 million, so in the last 30 days, you can be sure that this is the case without actually trusting any third-party entity other than the blockchain itself, right? So let's say in the hook example, you recorded what is the user's VIP tier, and in the next month, whenever user actually do another trade, there will be essentially kind of a hook that is looking up into the VIP table. And in that VIP table, you will see like this user qualifies for a certain discount. And this is how a dynamic fee hook can be implemented, by kind of combining the power of ZK coprocessor and the Uniswap's hook architecture. So, Brevis is very much production ready. To put things into context, to prove trading volume of 1,000 transactions on Uniswap, we on a very, very simple cluster of GPUs, very just like consumer grade GPUs, the cost of doing that is $1.8, and latency is 144 seconds. So let's say if you want to do this for the entire group of Uniswap user, what does that mean, right? So like, to put things into more detailed context, Uniswap on monthly basis process about 4 million trades. And Brevis using this very simple setup can handle about 19 million trades proof capacity. It means that you can handle almost 5 times of the Uniswap's capacity. And the monthly proving cost, if we want to prove the entirety of the Uniswap transaction, is just $7,000, comparing to the Uniswap protocol revenue, which is like 14.7 million, which this is just a tiny, tiny fraction of that. So basically means that the entire kind of cost profile and kind of a unit economy here really makes sense. If let's say through this type of VIP program, the Uniswap's entire monthly fee or monthly revenue can be improved even just by 1%. The return on investment of this type of feature is 20 times because of the low proving cost. So there are many different types of application you can do actually with Brevis, not only just on the hooks, but because today we're in the hook incubator program, I will kind of focus a lot more on what type of hook you can implement, right? So hooks are under the category of a use case, what we call data-driven DeFi. So in DeFi protocol, there are a lot of data that is accumulated in the protocol over time, such as LP deposit, withdrawal, swap event, liquidations. What is like the price movement of different asset? What is the open interest in per protocol? So many more, right? So you can access them all using Brevis, and then do computation on a collection of data you accessed. And the computation result then can drive dynamic protocol fees and dynamic protocol parameters. This is these are several examples that we think are very interesting and that can be actually applied to specifically Uniswap hooks. The trading volume-based fee discounting I already talked about. It's very simple to implement. We have a reference implementation for that, so that you can actually kind of use that as a basis to build other things. Another very interesting thing is the LVR compensation based on market volatility, right? So, because Brevis can allow you to now access historical price feed, essentially, like the TWAP record is now available to access. So you can actually build this type of hook that periodically receives the volatility proof generated by a Brevis application. And that hook basically can feed that into a dynamic fee hook. If the volatility is high, then the entire pool's fee can be increased, so that like the LPs in these pools will be protected more and essentially kind of compensated a little bit more, to reduce the LVR that is exploited based on on top of that, basically. So another very interesting thing, we have been looking at and also collaborating with some other teams on is this retrospective mining reward based on fee generated in each of the LP position. So today, if you think about the DAX farming reward program, it's very simple. It is time length-based farming reward. But time length-based farming reward is actually pretty harmful, because we have observed on chain with very clear evidence that there are smart LPs that are just removing their liquidity whenever the market volatility comes. They basically kind of monitor the centralized exchanges. As soon as centralized exchanges start to show high volatility, they will start to remove their liquidity from the from the market. So the end result for this is that you're distributing a lot and even majority of the farming reward to a bunch of LPs that are not actually providing liquidity dApps when it is needed most. So instead of just distributing farming reward based on the time length of LP deposit, what we should be also looking at is looking at what are the fees generated by each of the LP position. So, and we should put that as part of the farming reward distribution, weight to essentially kind of build this epoch-based farming reward distribution mechanism that at the end of each epoch, we do a retrospective examination of all the LP behavior and essentially kind of reward those LP who held the ground and provide liquidity even when the market volatility comes. And we kind of make these guys have higher weight when distributing farming reward. And there are some other ideas, such as token holding based fee discount. Let's say you are a protocol that you launched a pool on Uniswap with the protocol token and Ethereum, or with a protocol token and stable token. And of course, you want your actual user to easily get the token without actually paying any fee, right? So one way to do that is to essentially generate a proof showing that a user is a legitimate holder of the protocol token, the legitimate user of the protocol that you care about, using ZK proof generated by Brevis. And that ZK proof result will be recorded in the whole contract and to activate corresponding fee discount when user tries to trade or acquire or sell the protocol token, because they are actual active users of the protocol. So they should be benefited basically from that. And there are many other ideas such as IDO, free trades based on on-chain OG status. That is like, this is kind of a user gating feature where you can generate a proof showing that, hey, this user is really kind of a heavy user pre-token launch, and therefore they should be eligible to enter the market earlier than everyone else to essentially do this IDO process on Uniswap. That will be also be possible. And also for some of the OGs, you can essentially kind of offer them zero fee trading for protocol token to make it easier to get protocol token and have a easier price discovery whenever the token is actually initially listed on Uniswap. And user acquisition is also another thing where you can essentially say that, okay, I can generate a proof that this user is a big trader or holder of certain token in other protocols or in other pools that is competing with like whatever you guys build. And with that, you can actually kind of grant fee discount or even additional reward when the user let's say purchases this token in the pool and become a user of your protocol. And there are so many more ideas, but the high level thing here is that you can now think about like kind of the data not just in one point of time. You can start to think about the data in a much longer time horizon, basically the entire history of blockchain. If you want to access any data, any user that is not even exposed by smart contract call, right? Because we're proving we're not proving kind of a function calls. We're proving the entire blockchain states and all the transactions that happened in the past. So even if there is let's say a state variable that is not exposed, it's private, it's not exposed by any kind of a public function, you can still access that very easily using Brevis. And there are many more ideas that you can. And other than hooks, there are many other things you can build, like such as trust-free active liquidity management that you can essentially allow these on-chain hedge fund to prove on-chain that they're moving your liquidity or moving your LP position in Uniswap or any other DEXs or any other protocols, essentially faithfully based on a predefined algorithm and on-chain triggering condition. So they're not just arbitrarily moving things around. And you can also do trust-free temporal intent-based automation. Today, intent automation is really done in a centralized way that a user specify an intent and the triggering condition, and the automation solution will carry out the intent whenever the triggering condition is met. But it's entirely up to the automation services to to kind of judge whether this triggering condition is met or not. But with Brevis, you can actually directly prove on chain that the predefined triggering conditions, such as volatility, such as price target, is actually met, and therefore making this entire automation protocol, intended automation protocol, trust-free. And you can also do on-chain identity, a lot of on-chain identity related things such as proof of humanity, proof of pro traders, OG, proof of risk, based on different users behavior and kind of cluster them together, or figuring out common features for a group of users to kind of attack them collectively. And from kind of a user, from a per protocol or application perspective, applications perspective, you can also build user value profiling or UX personalization based on users' historical interaction with your protocol, and maybe with other protocol as well. And this, of course, applies to not only just like a UX personalization, but also user acquisition, similar to the some of the hook ideas that I mentioned, that you can essentially offer benefit for users who have demonstrated to be kind of a high engagement and frequent user for some other relevant or partner protocols for you. And there are many different other application scenarios that you can use Brevis for. But this talk is really kind of focusing on the hooks and how we can build that. So feel free to reach out to our Twitter, and also have my Telegram here in the slides. Feel free to reach out to me directly as well.
On the high level, as a developer, if you want to benefit from this new paradigm of finally you can have a database inside your D app, you need to write something. Of course, the ZK part is not something we can magically pretend it doesn't exist, right? Because all the trust-free, the good property of trust-free still depends on the underlying ZK circuit. But with our SDK, the developer does not need to worry about the low-level, ZK details. Instead, they can focus more on their intent. So I will actually show you actual API examples, then you'll immediately understand what I'm talking about, like MapReduce style data analytic APIs. On the high level, the workflow is the developer's off-chain component will run some query to the indexer or some RPC endpoints to collect the data points, right? It could be transaction, the receipts. Like if we talk about specifically the trading volume example, the trading volume, the amount will be emitted by the events, right? So that actually that exists in the receipts of inside each block in the transaction. And then the circuit will kind of process all these data points and say compute a simple sum. All those proof data is later passed down to Brevis gateway, because remember, after you prove this piece of data, all these thousands of transaction receipts are valid, and you do a sum over all the amount, you still have one last thing to make sure that all those blocks are not faked or forged, right? Just a second, I think I just can you still see my screen, or is...
Yep, we can see it.
Okay, yeah, I think it just it exits the full screen mode, right? So and that's why the Brevis service will also take care of all the proof aggregation and finally send the single succinct ZK proof on chain to the Brevis core contract. And finally, the result will be using a callback pass over to the DApp specific business logic. Like Mo mentioned earlier, the example could be you receive the trading volume as a result, and you can assign different VIP tiers to the address. And we kind of have a very high performant Golang based SDK, and then we realize, oh, there are more developers familiar with TypeScript, and that's why we kind of also add this additional a hybrid mode, I would say. So the developer will still write the TS TypeScript to kind of do the data preparation part, but the ZK circuit SDK will still be in Go. all the blue boxes will be the code, the DApp developer need to write. Now, kind of with the Uniswap trading volume, basically, let's just keep that as a use case in mind, and let's walk through as a DApp developer what exactly you need to work on, right? So the first thing is within your TypeScript, you need to say, oh, I want to initiate or I want to start a new proof request. Right? Well, you will realize what actually is the proof is actually another instance run by the developer. And inside this proof request is all the meat, right? So basically, we talk about for Uniswap, particularly the swap events, right? There are different fields we need to look at. Say, oh, this is the trading the amount, right? For each swap, the amount we are interested in, because finally our the logic requires we sum all the amount from the receipt, and this basically is within each receipt or event, what are the fields the developer need to be cared about and also provided to the prover, because the proving itself is more like the bytecode, right? And then you need to feed the actual receipt or transaction data if it's other use cases to the ZK circuit. So these are the examples, all the detailed breakdown of the contract address will be the Uniswap USDC pool, and the event ID is the swap event. And then the field index basically tells which field you are interested in, and the value is basically based on the meaning of each field. And then you might ask why we have, there are 3 events in here. There are 2 of them are actually the same event, same swap event, but different fields inside the event. And you might be asking why we need the third one. The third one is actually the event is emitted from the actual USDC ERC20 contract. It's the transfer event. Because when users interact with Uniswap, right, they always go through the route, not always, but most users will go through the swap router. And if you look at the events, the swap router will be the sender and the recipient, is inside the swap event. But that's actually, make it a little bit more tricky to know when you need to track the actual trading volume, you want to attribute to the actual user, right? Not the swap router. So that's why the sender of USDC actually tells you if the recipient of the swap is a router address, the actual sender, basically this is the transaction the user sends in USDC and in return gets ETH, right? So the actual sender in the transfer event is the user address you should attribute this amount to. Now it's the part, of course, we have fully working example code on GitHub. The app circuit part is also kind of try to capture the high level intent, right? So the first thing is you need to tell the Brevis underlying system what will be the maximum number of data points you need to handle, right? In this case, we only care about the receipts. Then it's up to the DApp developer to decide, oh, do I handle 100 or 1,000 or 10,000? Of course, ZK technology being still in early state today, larger data size incur close to linear cost. So basically, be prepared to pay more and also maybe also wait longer for the proof, right? And then the define is all the actual ZK circuit inside. But again, with Brevis team, Angie team did all the heavy lifting inside the SDK. You will see in next few slides, the actual compute is very intuitive. It closely matches the classic data processing or data analytic APIs. Like remember we talked about the trading volume example, right? So you will basically write like in a MapReduce style. You will say, oh, for each receipt, what I'm interested in is this amount field. And if you want to do a simple sum, we provide this ready to use basically essentially a reduce function, just SDK.sum, and that's it. That's the only code you write. So instead of writing any loop by hand or anything more complicated, this is all the computation you need to write, in terms of with a Brevis SDK. And after this, you are done. You just wait for, inside your DApp contract to receive the results. And here, to be able to provide more examples, we have the SDK.min, basically to give you the first block number. But again, these are more like we try to show different ways, different computations possible with the SDK. It's not strictly required as the minimal. If you only look for the minimal example, you don't need to worry about the block number, right? It's just the volumes. Okay, and in the end, you will say after your off-chain component compute this result, you need to output that so that your final on-chain contract can receive them, right? So this will be how you decide to encode the final result, because for the callback interface to be generic, we basically pass in a byte that require the app developer to parse it by themselves within the contract. And the simple way is just ABI encode pack to basically concat this fixed size field together, and then within your smart contract you match the encoding order and just to decode by byte. Yeah, and I think that's done. So basically the off-chain component is done, and that's it. Now we move on to the on-chain contract. Ignore the boilerplates. There is only one function you need to implement. It's also, the name is very self-explanatory, right? It's handle proof result. Basically, after the ZK proof is verified by the Brevis call contract, the Brevis contract will call this handle proof result of your DApp contract and say, hey, here is the result, right? The last argument, the bytes called data circuit output, is exactly what your Brevis circuit code output. Remember, we have this kind of a simple encoding, basically just concat this thing field together, right? And then in your contract, you will receive this concatenated bytes as one argument, and you will do something called decode output here. Because in the circuit, we concat this field together, and the decode is also very simple, just to find the right offset and pick the field and assign to a value, and that's it. So after this, right, after you have the decoded the circuit outputs, you have all the information you need. And next step is actually not implemented inside our example contract. Is what do you actually do, right, based on your own business logic to say, for example, assign a different tier based on the volume, or you can do something even fancier. That's kind of up to each app developer to decide. Yeah, a final note on Uniswap v4, right? So if you do want to go with the dynamic fee per trader based on the trading volume, there are kind of little notes here. When the pool was initialized, you need to pass in the dynamic fee flag. And also inside the before swap hook, remember to call the update dynamic swap fee based on, say, the trading volume, give the fee discount, or you could just do something directly, say it's a inverse of the trading volume or something, completed up to your use case and imagination. Yeah, I think that's all from my side for the end-to-end flow, and for any developer really want to get hands-on with Brevis SDK and get the feeling that instead of just a simple, there are some examples inside the Uniswap v4 repos for a dynamic fee, but I kind of feel it's very limited if your dynamic decision is purely based on a current transaction, right? That's, say, for example, some examples say you want to do a different fee based on a trade amount, but that's actually, I wouldn't believe it's a good idea, because let's say you give some preferential treatment to some amount, what will happen next? It will actually make all the traders optimize their trading amount to match your code, right? Because everything is public on-chain. So I think without a trust-free historical access, the dynamic fee implementation purely based on what's currently available inside this trade, the use case or the actual applicability is very limited. Yeah. Okay. I hope feel free if you run into any issues. We went to different hackathon before, like at Stanford, and had many successful projects implementing way more complicated stuff, not only limited to Uniswap v4, right? But with the Uniswap v4 hooks, we are very excited to see people leverage the power of this whole trust-free historical access, and give the hooks a kind of completely new applications, right? Yeah, that's all from my side.